I'm Long John Aargon. Today, I'm going to measure the heat capacity of my bedroom. This might be particularly relevant to students in Chemistry 12, who determine experimentally the changes in energy of various chemical reactions. Normally, this is done through calorimetry experiments, and you'd use a well-insulated thermos. Before measuring the heat of a particular reaction, you would need to determine the heat capacity of the thermos, or, in my case, the bedroom. Now remember, the heat capacity is the amount of energy needed to raise the chunk of matter, bedroom or thermos or whatever, by 1 degree Kelvin or Celsius. A bedroom is probably not as well insulated as a thermos, but nevertheless, this experiment will be helpful if anyone wants to measure the heat of reaction of something large, or if you just want to measure how much energy it takes to heat your bedroom in the wintertime. Let's get started and see what's in the treasure chest. Look at this. We've got a thermometer, a heater, an energy meter, fan, and cell phone that we can use as a stopwatch or a timer. Awesome. I think we're all set. Arr! Captain Aargon again. Yes. Now, I've set up the lab as we need it to measure the heat capacity of the bedroom. Let's take a look around. So here we are in Captain Aargon's bedroom. Position the thermometer over here on the wall. I'm not going to be able to focus in on it, so you'll have to take my readings at face value. Now over here I've positioned the fan to help circulate the hot air and the cool air. And down below is the radiator. Now I've plugged it in through a power bar and this energy meter that I've borrowed from the library. I've set it to measure watt output, so that we can monitor how much power the heater is putting out. Now the heater measures, it says that it puts out 700 watts, but just to be sure, I thought we could measure it with this nifty device. So let's turn everything on and get started. Power's on, full, fans on, circulating, and then we'll set our stopwatch timer to see how long it takes to change the temperature in the room. Let's just reposition that one. Now, I could stay in the bedroom, but I have to remember that my body is also putting out heat. So I'm going to leave the room and come back in about half an hour and see if the temperature's changed. Have to take a reading, and the thermometer is reading 11 degrees. So we'll check back up on it in a half hour's time. Until then, we'll just have to amuse ourselves. Captain Aargon here. It's been about 30 minutes, so let's step inside the bedroom and have a look, see if the temperature's gone up. and I'm still reading 11 degrees, so we'll have to come back and check up on it in another half an hour. Arr! Long John Aargon here. It's been 60 minutes, so let's step inside the bedroom and see what the temperature is. Well, the temperature is still 11 degrees, so we'll have to come back in another half an hour. Arr! Captain Aargon here. It's been 90 minutes now, so let's step inside and we'll see if the temperature's increased. Okay, I think we've got it this time. We're reading 12 degrees. So let's go on outside and we'll make some calculations and turn off all this equipment. I meant to mention earlier, we were reading, when I first turned on the heater, it was reading 650 watts thereabout, and when I checked on it at 30 minutes and 60 minutes, it was also around 650, so now we're at 670, so we can take that into consideration in our calculations. So from thermodynamics, we know that the heat is equal to the heat capacity of the calorimeter multiplied by the change in temperature. The change in temperature we measured to be 12 degrees Celsius minus 11 degrees Celsius, the final minus the initial, which is 1 degree Celsius. Now, we want to find C-cal, and we need to first calculate how much heat the heater put out. Now, I mentioned that the watt meter was reading 650 watts at T equals 0 minutes, T equals 30 minutes, and T equals 60 minutes. And when we checked at it at 90 minutes, it was reading 675. So the average heat output was about 660 watts, which is 660 joules per second. Now we had the heater on for 90 minutes, so we need to multiply this out to see how many joules of energy. So the heat is 660 joules per second multiplied by 60 seconds in 1 minute multiplied by 90 minutes. So our units cancel and we're left with 660 times 60 times 90, which is 3,564,000 joules. Okay. So now the heat capacity of the bedroom is the heat divided by the change in temperature, which is 3,564,000 joules divided by 1 degree Celsius, which is again 3,564,000 joules per degree Celsius. So that's how much energy it takes to heat the bedroom up by 1 degree Celsius. Now, if we want to know how much we're going to have to pay for the energy that we use from the power company, we need to consider how many kilowatt hours we used. So we used, on average, we said 660 watts. We need to convert this to kilowatts. So there are 1,000 watts in 1 kilowatt. And we had this on for, we need to put this into hours. So we had 90 minutes. And then put minutes into hours. So 1 hour has 60 minutes. So we're going to be left with kilowatt hours. That's 660 divided by 1,000 times 90 divided by 60. That's 0.99 kilowatt hours. Now, if the power company charges us about 10 cents per kilowatt hour, we're going to be paying Well, we just multiplied 0.99 times 10. It's going to be about 10 cents. 9.9 cents. Or to our sig figs, we were measuring things in only one sig fig, so this is about 10 cents. Okay, so that wraps up the lesson with Long John Aargon today. I hope you had fun, because I sure did. Bye.